So hey guys, this is Nitin and I'm back with yet another cool project. Today we are discussing about controlling IoT devices over the local network or internet. So what's cool about this project is today we are going to utilize these teeny tiny microcontrollers, also known as Node MCUs, or you can call them as ESP8266. You can see I have two variants here. Both of them are ESP8266 modules, and I also have another microcontroller, and this is much superior than the previous one. These are called ESP32s. They are much more powerful. So today in this project we will be discussing about how we can utilize these microcontrollers to connect wireless switches, let's say over your local network or even over the internet. And one thing that makes this project stand out is we're going to utilize Micropython for this. So yes, no Arduino code, we will be using Micropython to run the code. And these devices also need not to be exposed over the internet, so they can continue to work on your local network, and you just need to deploy a server which is publicly available, and these microcontrollers can basically sync their state with the server so that you will always have the feedback whether once you clicked on a switch to turn on, whether it is on or not. So I'll quickly jump over to my VS Code, and as you can see I already have pulled the code, but you can always go on my GitHub repository and then you can clone the code from here. And as you can see, the project is actually 6 months old because I've been working on it, but I did not get time to do a video about it. But here we are finally, and we are doing it. Also, I forgot to add readme, so I'll probably, the time this video comes out, I will be adding the readme. So I have already pulled the project here. You can git clone it, and so let's discuss about the project structure, because it's a bit different tutorial. It's not traditional Arduino. We are going to use Micropython, so we should understand some of the features and requirements that we can use to work with Micropython and these microcontrollers. So first and foremost, we have the script section here, which are actually useful scripts for us to flash these devices with the Micropython, and then we can utilize the AMP is a command line utility which we can use to communicate over serial port to these devices. And same thing with Picocom. So Picocom can read the serial output from these devices, and AMP can be used to let's say copy your code into the microcontroller. So that means with traditional Arduinos we had to build it every time we made some changes, but with Micropython, once we have flashed the firmware inside these microcontrollers, we just need to copy the source file and it should be interpreted and ready to go. So the development on Micropython is much faster than the traditional Arduino, so we will be doing that. And also on Node, we have two kinds of MCUs here. One is called ESP8266, which is this one, and the second one is called ESP32. So both of these microcontrollers actually requires different firmware. So first of all, we will be dealing with ESP8266 chips. So if I go to the flash script here, you can see I already set up the constants here. So firmware name is basically the file name which is going to be downloaded on our disk, and the firmware URL is the bin file which is available on the Micropython website. You can always go to micropython.org and look for the firmware downloaded from there. We'll be doing it for the ESP32 MCU, but for now, since it is already in place, let's try to flash one of the devices and then see how it works. So the commands are all listed on the website. You can always check there. So the thing is very simple. You need to install this esptool.py, which can be done using pip install esptool.py. And then once it is installed, you can just provide the port where the device is located, the baud rate at which you want to flash, move the data, and then flash file. So for me, because I usually work on these devices, I created this handy script and we will be utilizing this only. So let's get started. So this is our ESP8266 microcontroller, and I'll be connecting it. So you can see this is the microcontrollers, and it requires a standard USB micro USB port. So I'll be connecting it with that, and once that is done, we can see if the device is actually connected or not. So let's come over here and try to see if the device is available or not. So we can do ls, /dev/tty USB, and there can be multiple devices, so I'll just try to list out all the tty USB devices connected. So we have only single device connected so far, so that means our device is connected and we can go on to the next step. So next step is basically to flash these devices with the Micropython. So in order to do that, how we can do it, yeah, so if you're cloning the script for the first time, you might need to change permissions, so I'll do that quickly. So I changed the permission so that I can execute these scripts, and now we are ready to flash our MCU with the Micropython. So in order to do that, I'll go to the flash, and then I just need to pass the path to your MCU. So in our case, we already checked, it's called /dev/tty USB, and it's on the 0th index. So I'll do that, and I should probably start the flashing procedure. Yes. So as you can see, we get the information about the chip. It's called ESP8266, and because the firmware is correct, it is trying to flash the MCU with the Micropython firmware. Should be done in a minute, so let's wait for it. Okay, so this is done, and just to confirm that we have our device flashed, what we can do is we can connect to the MCU and see if there is a Python interpreter there or not. So let's introduce to our secondary script called alias, and what this basically does is to interact with your Micropython based MCUs. You can utilize the tool ampy and picocom. So because this command always I need to type the baud rate and the port at which I want to connect it. So I set up a alias script, and how we can utilize is basically instead of calling it out, we need to source the script. So source script/alias, and then we'll need to pass the device which we are going to use. So it's called /dev/tty. All right. So with this, we have sourced the script. That means all the variables that we have set up in the script are available for us to use. So now we don't need to type the path to the device or baud rate or port at which it is connected. We can simply work with that. So a quick example here is called connecting to the serial port. So traditionally we can do something like this. We can use picocom and then pass the parameters, but we have set up an alias for that. It's called MCU, and soon enough when we type MCU in our console, we should see that it is connected to our board. So this is the port where it is connected, and this is the baud rate. So quick tutorial here, since I mean, if you guys are familiar with Linux, you know how complicated it gets to work with Vim, which is a text-based editor, terminal based text editor, because the commands are a little bit off than usually what you run in the CLI tool. So it's the similar thing with the picocom. So how we can do is, you can see the terminal is ready. However, this is just reading or listening to the serial port, whatever the MCU is writing out. However, there is no program on the MCU, so we can't read anything. So if you simply press Ctrl+C, you'll see we get a Python shell. So this Python shell is actually running on the Micropython. So we can quickly import OS, which is available on the MCU, and then we can say os.list. So you can see there is only a single file there. It's called boot.py. You can even open it and then read it, but I'll not go there. So now to exit out of this Python shell, what you have to do is you have to press Ctrl+A followed by X. Notice if you do something like Ctrl+D, which is standard for exiting out terminals, it will just restart the MCU. So that means in order to exit out the cell, you have to type Ctrl+A and then X. So with that, we are out of our ESP8266 Python console, and we are ready to put the application. So the app here is called main.py, and the name is strictly main.py because Micropython expects it to be the entry point for any application that you are putting there. So a quick walkthrough to the code. So we are using Micropython to connect to our local network. We have set up our credentials here. So I've already opened a guest network on my Wi-Fi. It's called IMIoT, and then the password is super secret, obviously. And then we have server. So this server, basically how we can find out is we are going to utilize this PC as a local server for now. So we can type hostname -i, make sure it's capital I, and you can see the IP address is connected to my localhost. So because it is connected with both wired connection, Ethernet, and also Wi-Fi, so we have different IPs. We can utilize any of these. So I'll go with the Wi-Fi IP address. So this is the IP address of my PC where I'm currently running the code, and this is where I will be starting out a server with which the Node MCU could connect, and then we can establish a connection between them. So this is the same IP I have put up here, and notice I also added port 5000 because our application, which is a Flask based application, is going to be listening to that port only. You can always modify these things if you know how Flask works. So I can go back to the main application. So we have some utility function to connect to Wi-Fi, and if it is connected, we will just bypass it. In case if it is disconnected, we'll try to reconnect. And then there's some standard configuration. So these are called pins. So if you check out the board, you will see there are the pin markings on the board itself. And the number here, if you see, these are the standard GPIO mapping. So these are called GPIO pin numbers, and this D0 you see here, these are actually printed text on the board. So I have marked it as it is so that we know what pins we are using. And later we have this header section where we define whatever the data is going to be exchanged between the server and the MCU. So you can see the D0. So basically all of these switches can be utilized as an input or output on the MCU. So basically you can connect any appliances, or you can even utilize a switch module, relay module, to basically connect handle high voltage devices. So if you see here for the D4, I have renamed it as onboard LED. Why? Because this is the D4 pin is internally connected with the onboard LED on the MCU. So whenever we try to on or off the D4, the onboard LED should also switch. So this can serve as a good example for us to test whether our script is working or not in the entire application. And also there is one limitation with Micropython that I have found out on these ESP8266 or 32 devices. That is, when you check the current value of the pin, I mean, either it can be high or low. So if it is low, that means it is actually on, and if it is off, that means it is actually off. So just to deal with that problem, I have a utility function here which basically parses the value and then converts it to a string. So with that, I think we can move forward, and these are standard application. You can see how it works. It basically sends some update, and then it also fetches some update, and then updates the local pins, and same thing happens on the application side on the server. So first of all, I'll just deploy this application. So the way we can do is we can use MCP. MCP again is an alias we set up in the script, and what it does is it basically does the mput command. So you can either type mput or MCP for short, and then followed by the file. So main.py is the application which we are going to put inside our NodeMCU. So I'll just quickly do that, and with that our source code is now uploaded to the microcontroller. Now see how simple it was. If you had to do with Arduino, you had to compile it from source and then you would upload it. I know Arduino is still much more efficient, but we are doing development, and I think it's much better for us to have a feedback and quick development. Now our application is running on the MCU, and we need a server where the device could connect. So in order to do that, I will start the application, which is the server where the MCU connects. And one thing to note here is it specifically requires these tools in order to work with that. However, going on, I think is not required for now because we are running a development server, but you need Flask. So these are already installed on my system, so I'll just simply go ahead and launch this. And notice here we don't receive any requests here, and the reason for that is because every time we put some file inside the MCU, it won't start automatically. So one way to do that is either you can disconnect the wire or connect it again, or there is a reset pin here. If I can show it on the camera. So there is a reset pin up here. If you press this key, what happens is it will restart the device, and with that there should be some thing happening on the device. Yeah, you can see the LED is turning on. And if we switch back to our screen, you'll see we started receiving some request on our web server. So what this means is our device is now connected to the server, and we can go back to the browser and we can control some switches. So when we launch the application, there are a few more things here. You can see there is a auth token. So this auth token is basically required for us so that we can connect to the device. So let's open our browser and then visit the local server. So it's running on port 5000, so I'll go there, and it asks for the token. So, and you can see in the bottom it says connected devices 1. That means we have one device to connect to the server. So if we write the correct token, we should be able to log in, and you can see we have a device here. So it says office area because in the header we set the alias as office area. That means this device is now known as office area. We can always change it, and once we go inside there, you'll see all the switches available for us to work with. So as you can see, the LED is running on, and it was connected to D4, which is onboard LED. In the app it shows off because it's basically altered for the Micropython firmware. I don't know why they did it, but anytime we turn it on, so the output on the pin, actually the pin D4 is actually high. However, the onboard LED goes off. This is how it works, but it's a quick way for us to check. So if you interface it any relay module, it will still work because on means on here, but for the onboard LED it becomes different. So if I turn it off, you'll see the LED comes on. Same thing back, we can turn it off. Same thing, there is another onboard LED, it's on the D0. As you can see, it currently says on, so the LED is not on actually, but if I try to turn it off, you'll see another LED turns on, and same we can turn on and the LEDs will go back off. So this is something with Micropython. So whenever the pin is high, the LED actually goes off. However, we can still test that our application is running, and we can always go back, and then we can even log out from here. So now we will see how we can connect two devices. And what's cool about is once you started this server, you do not need to worry about it. You can connect as many devices the server can handle, and you just need to change few configuration from the device side. And as long as the token is same, they can be logged in, and both of the devices will show in the same interface. And if you choose to change the token, then you'll have to log in with that token to access that device. So while this device is running, what I will do is I'll connect another device. So I have another ESP8266 here, so I will quickly connect it. And with that, let's see the connected devices. So I can again do ls/dev/gty usb star, and now we have another devices named as USB1. And since we set alias for the USB 0, so whatever command we execute, those are related to USB 0. So now to do with USB 1, either we can again source the alias in this terminal, or we can even open another terminal and then we can source the alias for that particular device. So source script/alias. So now we are sourcing for the USB 1. So with that, what happens is we have two terminals open up here, and we are going to control both of these devices through this terminal. So let's quickly flash this second MCU. So script/flash, and I can just do this. Okay, and then we have to point it to the device. So it's USB 1 for now. So we will quickly flash this as well, and we can basically see both of these two devices will be connected. And if you type the MCU in the first console, I think you would be able to see the console logs. So anytime you switch something off, you will see it here. For now, I'll just exit it out. So our second device is also soon going to be flashed, and with that I think we can push the files. So I'll keep the SSD and password same because it has to connect to the Wi-Fi, and also the server address, and also I think auth token can be same. Only thing that we need to change here is called alias. So this alias is basically the name of the device that we can use to identify it. So I'll keep it as let's say ESP second. All right, and then we can basically copy this device to our second MCU. So I can do mcp main.py, and with that it should be uploaded. So once again I'll go back to the interface and then I will log in. You can set any token there, and even if I refresh, you can see it says only one device is connected. Why? Because anytime we upload some code, it does not start automatically. So one way was to hit the reset button on the device, and second way I'll show you is called soft reset. So you can type MCU and then you can press Ctrl D, which will restart the device. So it is trying to connect to the Wi-Fi, and I think it's connected successfully. So if we come back up here and refresh the page, and now it says connected devices 2. So now we will quickly log in with our token, and as you can see, now we have 2 devices listed up here. Now we have ESP second, so we can go there and then we can try to turn on or off and switch. And now one more quick note I'll add here is because these devices basically are not exposed publicly and it only sync their states with the server. So anytime, let's say some packets drop or there is some miscommunication between the server and the device, so what happens in that case is first of all, the device will actually not show up in here because it is not connected, because its state is not synced. Second thing is, even if you, let's say, turn off, it says turn off, but anytime you refresh the page, if the switch is not turned off, you will see it will still show that it is on because the state has not been synced with the device. So that's some cool feature here, and we can come back here. So this was the tutorial about Micropython and how you can post your application on the MCU using Micropython. And one more quick note here, if I press Ctrl C here, you will see it just interrupts the execution. That means our second device now should be disconnected. So if I log out and if I press refresh, it will take some time to sync. And let's say we turn it on, and then if I press F5, you'll see it always goes back off. Why? Because the state is not synced with that device, and soon after some time our server will basically remove this device from the memory. So again, I'll press Ctrl D to restart it, and remember, when you start some application from a terminal, you should press Ctrl A followed by X to exit the terminal so that the program still keeps on running. And in the logs, you can see here it constantly receives some posts from the 2 different IPs. That means both of those devices are actually sending their request to sync the states. Alright, so I think this was it for the tutorial. Please share some of your valuable comments how you can utilize it and if it is useful for you or not. And in the meantime, I think I can do one little adjustment here. So instead of putting out alias here, I will say device name. And then let's keep it same, office area. Alright, so with that, I think it is done. And you can find the links to this source code in the description. It is available on the GitHub. I'll also try to update the README. And with that, I think we can sign off. Okay, guys, thank you very much. Please make sure to subscribe to the channel, and yeah, do share it if you find it helpful. Thank you.